Good evening, students. Am I audible?
Good evening, sir. Yes, you are.
You are not audible, Mr. Rani.
Sir, am I not audible?
Just wait. Just.
Hello, sir.
Am I audible?
Yes, sir.
You are not
Good
audible.
evening, sir. Sir, am I not audible or what? Just not any.
You are not audible, Jyotsna Rani. Prabhudatta Satpathy,
Sir, you are
please
audible.
unmute.
Uh,
Good evening, sir.
Oh,
okay,
sorry.
sir. Something problem.
Good evening, sir.
Oh, good evening. Good evening. Actually, okay, okay. Yes, yes. Now it is audible.
Good evening, sir. Now
Good
am I
evening.
audible?
Yes, yes, yes. Jyotsna Rani, you are audible. The speaker
Thank you,
was
sir.
on mute mode actually. So today is Utkal Divas, the 1st of April
Yes,
is
sir.
celebrated as Utkal Divas in Odisha, where when our Odisha become an independent state from the during the pre-independence period. So hopefully you are doing well, and can we wait for another few minutes for joining of other students?
Yes, sir.
So before that, if you have any doubt or anything wish to share, you may. Today's class will be covered the block 3 of MEV-19 paper of your MSc Environmental Science program, and this paper is mainly deals with the statistical analysis um, that relates to your some mathematical formulations on how to calculate the deviation of your data collected from the absolute value or true value, and this part is mainly deals with the data analysis or data interpretation in your project work. The sequence of your project work is first identification of problem, then formulation of a project topic, then on consultation with your supervisor design a research plan, which include hypothesis testing to target a study area, followed by the sampling. Sampling. So from your sample you will collect data. That data may be primary data or secondary data. So if it is live data, that is data of your sample collected, then this is known as your primary data. It includes if it is survey work, it includes the data like survey report, that is your interview questionnaires. And if it is an analytical research, then your data will be collected from any sophisticated instrument or any chemical reaction, any titration technique, any experimental work. So the data collected are known as primary data. And the secondary data, as highlighted before, it was collected from the historical data or past data, which are already published in some papers, journal, article, book chapter, magazine, newspaper also. If you and that data should be cited properly. If you are not citing your secondary data, then that data will be come under plagiarism. So plagiarism is deals with the ethics and values. If I am borrowing some data from any related published paper or published article, then I have to give credit to that author or to that researcher or to that scholar, that he or she have done this work, and he or she is published these data in his paper or article, and accordingly you have to cite. That citation reflects in their um, impact factor, or in their I index, which that means if someone is publishing something, and if we are borrowing something from that published article, then it is an ethics. It is a value that we should give credit, we should give appreciation to that work or that published data, so that the moral of the research work, the ethics of the research work should not violate. And to catch that or to investigate or to inquire that your project work or project data is how it is authentic, there is a software which is known as Turnitin. Turnitin is a software that is a plagiarism software, and it cost around, I think it is cost around 5 to 7 lakh. I think it is 5 to 7 lakh. And if you put your project report in that software, then your each and every line, each and every word, each and every letter will be under scanner in that software, and that software will highlight, that software will result that your word, sorry, your letter, your word, your sentence, your mathematical equation, your data, if these are borrowed or copied from any published paper or article or book chapter or magazine or newspaper, then it is give some color. Just see here in my one of my paper. Just see here, this is the plagiarism test. Sorry, I am not shared my screen with you. So my screen is visible, students? Is it visible?
Yes, sir.
Okay,
Yes, sir.
okay. So just see here. Uh, let's see here. During my PhD work, I have checked my PhD thesis 7 times in plagiarism software, and if you are interested for PhD work, then your plagiarism should be less than 10%. If your plagiarism is more than that, your thesis will not be accepted by your university. Okay, just wait. I have checked my one of my paper in NIT Raulkela also. Mm, just wait, just wait. I am trying to show you that how a plagiarism report, how it is looks like. এটা କେମିତି ଦେଖାଯାଏ ଗୋଟେ plagiarism report, ସେଟା ସମସ୍ତେ ଜାଣିବା ଦରକାର. All should know that each and every line, yes, this one. Yes, and this is my PhD thesis, which is checked on 16/4/2024 on last year April month, and just see here the lines. Is it visible, students, clearly?
Yes, sir.
Okay, okay, just see here. Just see here. Yes, these are the lines. These are the colored lines. Just here, connected to an aryl or alkyl group but not hydrogen. This particular sequence of word was already published in some research article or review paper or book chapter, etc., etc., and this creates a plagiarism line in your in my thesis. So like this, or is plagiarism. Just see here, or group. So these are all plagiarism words now. So how one may ask that, sir, or is if I am not allowed to write or in my project report, you are allowed, but your continuous three word may not be continue from may not, that means ତମର ତିନିଟା ଶବ୍ଦ continuously କୌଣସି ଅଲଗା ପେପର ଶବ୍ଦ ସହିତ ମ୍ୟାଚିଂ ନ ହେବା ଦରକାର. your continuous three word must not match with the word in other published research article. That means these are the three words which are continuously copied, but here between alkyl and phenyl, that see here, or phenyl group, that means these two are plagiarism. So like this, your words that are not been copied or your own words that are highlighted here as your plagiarized words. Just see here, these are all these and here just see various colors are there. One is violet, one is green, one is pink color. So these colorations are for different published papers. Okay, just see here, at the end at the end we have the paper names or the published um, papers with different colors. And here just see here, 19% similarity index. That means overally my this PhD thesis having 19% of plagiarism. Just wait. So my this thesis report carries 19% of similarity index. That means it is having 19% plagiarism, which is not allowed by the university for the award purpose, PhD award. So your PhD thesis must have below 15% of, sorry, below 15 or 10% of similarity index or plagiarism, and everything is specified: 11% from internet source, 18% from publication, and 3% from student paper. And here every percentage was written and from which paper it is borrowed. And yeah, and all the related published papers are highlighted here as in different colors: the red, violet, pink, blue, green. So like this, you have that plagiarism effect on your research report or your project report. So today we have the
Sir, this paper will attach in the sir, synopsis. This
which, which paper?
the last page reference. Yes, plagiate.
No, 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 no. This is not attached. Actually,
Okay.
if you are, let us, you are submitting your PhD thesis or any project report in your institution, then
Okay.
your institution will check
Culture.
in
Verify.
turn it in plagiarism, that
Hmm.
your plagiarism is below 15% or not. If
Okay.
it is below 15%, and this work will or this plagiarism report will come within 10 seconds,
Hmm.
because that Turnitin software is the cost is more than 5 lakh. And in I think in Odisha we have some selected institutions where Turnitin software is there. It is not available in reputed institutions also, because its cost is too high. Okay. So I have checked my plagiarism in NIT Raulkela, in GM University Sambalpur, then in Ravensa University Cuttack, like this. Okay. So from the student side, as a student, I have to check my report before submission, that whether the plagiarism report or plagiarism or similarity index is below 15% or not. Okay. So for your project work, this 15% might not be there. It was actually very difficult to make it below 15%, because you have some similar words will be there, some similar mathematical equations will be there in your project work. So you have to, for your project work, I think it is below 25%. I think IGNO is IGNO is allowing the PG students to submit report which is equal or less than 25%. Okay. So this report will not attach to your final project report. It will be checked by your institution. Checked by your institution. Okay. So let us comes to our part, that is data interpretation or data analysis. And in data interpretation and data analysis, many statistical methods or mathematical formulations are used to analyze or to interpret the data we have collected from our sample, and that data should be primary data, number one. And depending on the type of research I am carrying out, and depending on the objective of my research work, I have to plan that what are the different parameters I have to analyze based on my objective or based on my expected outcomes. So the different statistical datas which are which are needed for interpretation, That statistical data may be, yeah, our central data. Central data means it is more or less related to mean, median, mode, range, then standard deviation, variance. Then we have some a different comparative test that for a specific project work, I have two different group of datas, and I have to compare both the groups with different test. The test is like chi-square test, t test, f test, ANOVA test, that the analysis of variation, which is known as ANOVA test. So some tests are there. So before going for a particular project work, you have some sound knowledge on these parameters, that which analysis I have to carry out, and which comparison or which conclusion I have to make from my research work. So so just see here, I have yes, this one. So this is descriptive analysis. So I have uh, planned to planned to discuss these things today with this PDF, because this PDF is very student friendly uh, material is there, which is help us to understand the things easily. Okay. So this is descriptive analysis. Just I am showing you what are the things we will cover today. This is block 3. Just see here in block 3 we have from unit 7, it is descriptive and statistics 1, descriptive statistics 2, sampling distribution, statistical analysis 1, statistical analysis 2, and analysis of variance, which is known as ANOVA test. Okay. Analysis of variance means it is ANOVA test. So it is not possible to cover all the things within 2 hours. If we are going for a clarity or understanding of things very clearly, that is not possible to cover 198 pages within 2 hours. But we have to minimize the minimize or stick on different things or different parameters we have to stick beyond, which are frequently used for different project work. So these are the things we have to carry out. So I have this PDF with me, which is student friendly, and it is I think this PDF will clear your understanding. And the first part that deals with the measure of central tendency, which is mean, median, mode. So in this part we have the introduction. I skip the statistics. What is statistical distribution or distribution of statistics? It is statistics is mainly of two types: descriptive statistics and inferential statistics. Descriptive statistics, it includes graphical, central, dispersion, correlation, and regression. And our inferential, it includes estimation and testing of hypothesis. So for a project work to execute, the descriptive statistics is very much helpful. That includes graphical representation, the calculation of central tendency, mean, median, mode, and range. We have dispersion, regression, and correlation. So these are very much useful for any project work. So descriptive statistics, it includes histogram, bar chart, pie chart, OGIF curve, box plot. So nowadays, different type of AI. representations or AI technology came. So mm, um, that's why this descriptive statistics include all these. So descriptive method include for a summary of data, we have central tendency or measure of dispersion. Central tendency includes mean, median, mode, and measure of dispersion include variance, standard deviation, and range. Inferential statistics, we have two types, that is testing of hypothesis, that includes estimation and testing of hypothesis. Estimation technique is to extract information about the population of the sample, and testing of hypothesis, this method is used to test the significance of a statement about a problem. So this inferential statistics, this is quite relevant to our project work, but the descriptive statistics, it is more useful for data interpretation or data analysis. Just wait. Okay. So measure of central tendency, as we know, we have mean, median, mode. Three central tendency measures are there. These are some properties. I will share this PDF with you. Don't worry. Okay. So just read out all the things here. I am just trying to cover the main part of these descriptive statistics. Mean, as we know, this is the average of all the data we have collected for a specific project work, and this is the average or mean. It is equal to sum of all observations by number of observation, and in mathematics, the mathematical formula will be x bar. It is now mean x bar. It is equal to summation of xi divided by n. So x I and I is from 1 to n. So let us, we have a series of datas. We have five datas, 23, 24, 25, 35, and 32. If I will just summation of these numbers divided by 5, I will get the answer 28. So 28 is the average or mean of all these datas. Then this is the direct method. If I have some datas with some frequencies, that means just see here, I have some datas with 5 frequencies, like this one, 0 to 4 hour. It is time spent by 690 students. 4 to 8, 285 students. 8 to 12, 20 students. 12 to 16, 5 students. So how to calculate the mean? It is frequency into the first data plus frequency into the second data, so on, divided by total frequency. It will be the mean. If I calculate the, see here, frequency is 690. Sorry, frequency is 2. This is the frequency 0 to 4. So the mean point will be, it's from 0 to 4, it is 2. For 4 to 8, the middle point will be 6. 8 to 12, it is 10. 12 to 16, it is 14. That is 0 to 4, 2 into 690. Let's see here, 2 into 690, 6 into 285, 10 into 20, 14 into 5. Total divided by total number of students. That is the frequency 690, 285, 20, and 5. I will get the mean time spent is 3.360. So for a frequency, for if you have direct data or a frequency of datas, then the calculations will be different. For direct data, it is direct summation divided by total number of species or total number of data you have. And for a frequency related data, you have to multiply the frequency with the data we have in every phase, and divided by the total frequency of the data. Then the median, it is the central data which is used in ascending or descending sequencing of data we have collected. and the median is the representative of a data set. That is very important. It is a representative of a data set. And if you have a sequence of data in ascending or descending mode, then you have to calculate that the total number of data is odd or even. If it is total number of data is odd, then the median will be n plus 1 by 2, where n is the total number of data we have. That means if I have just see here 1 to up to 9, that means 9 datas are there. So if it is odd, 9 means it is odd. If it is 9, then it is odd. The formula will be n plus 1 by 2. That means 9 plus 1 by 2, that means it is 5. So if I arrange these things in ascending order, then the order will be like this: 21, 25, 36, 43, 49, 53, 56, 63, 71. And out of these, the fifth term, that is 49, will be the median of this sequence. If it is odd, it is n plus 1 by 2 to find out which term, to find out which term is the median. So if I have a set of data with even number, then your middle plus 1, that means n by 2, n by 2 plus 1 will be your central data, and the median will be summation of these two divided by 2. That means here your 49 and 53, it is your fifth and sixth term. And if I calculate the mean of 49 and 53, the calculation will be 51. That means for even number of data, the median will be the central number, and the next number, the fifth and sixth value, and the mean of the two terms will be the median. So like this you have to calculate the median for odd number of datas and even number of datas. And the important thing is to arrange all the datas in ascending or descending mode, and you are recommended to write all the datas in ascending mode, chotoru bodo ascending lekhiba, so it will be easy to find out the median. And similarly the mode is a French word having the meaning fashion. It is particularly useful in the study of popular size. For example, a manufacturer of shoes is usually interested in finding out the size of most in demand, so that he may manufacture large quantity of the size like median mode, etc. So like this, so mode କହିଲେ ଆମେ କ'ଣ ବୁଝିବା? Mode is a data set having it mode ଆମେ କାହାକୁ କହିବା? Which number is repeated maximum. It is no
Frequent.
frequency, right? It is a frequency mode. So the relationship, if the relationship between mean median mode, if your data are symmetric, then mean median mode all are same. If it is asymmetric, then mean may be greater than median, may be greater than mode, or mode may be greater than median, may be mode greater than mean. These things are there. The measure of dispersion, it is more relevant to your standard deviation as well as variance. So standard deviation is, just see here, measure of dispersion. It is maybe absolute measure or relative measure. If it is absolute measure, then it is maybe range, mean deviation, or standard deviation. Mean deviation is also known as the quartile deviation, in which we are just segmented or divided all the data into 4 segments. The first segment will be Q1, Q2, Q3, and Q4. If I have, let us 20 number of datas, then my Q1 will be up to 5, then Q2 will be 6 to 10, Q3 will be 11 to 15, and Q4 will be 16 to 20. So like this, I have to find out the quartile deviation, that is Q1 to Q4. Then standard deviation, that means from the mean value, how far my collected data is deviated. And all these things, that the range, mean deviation and standard deviation, these are under your absolute measures. And relative measures, that means it is more or less relevant to the deviation, sorry, it is not the deviation, it is coefficient of range, coefficient of mean deviation, coefficient of variation. That means in coefficient of range, it is calculated as the highest value plus lowest value divided by highest value minus lowest value. So we will cover all this, okay? So we have the range. Range is nothing but your maximum value minus minimum value if you have a set of data, and you just arrange all the data in ascending and uh, descending mode. Then the maximum value minus minimum value will be your range. Just see here, I have this set of data, and all the data, I think it is not in ascending mode, it is in shuffling mode. Then the maximum value is 76 here, minimum value is 23, so range will be highest value minus lowest value, so it is 53. Here it is come the quartile deviation. I have just point out you that quartile deviation, it is just the division of your set of datas with four quartiles. If I have 20 datas, then the four quartiles will be from 1 to 5, 6 to 10, 11 to 15, and 16 to 20. So just see here, this measure of dispersion related to range, and it removes the drawbacks of range up to some extent. It is defined as the difference between third quartile and the first quartile divided by 2. The third quartile, that is from 16, so that is from 11 to 15, and Q1 is from 1 to 5. So it is divided by 2, it becomes your range. Just see here, I have a set of data with 15 students, that is 60, 67. Let us, these are the marks they have got in some subject, in any subject, let us be mathematics. So the first step is to arrange all the things in ascending order. Then now compute. Just see here, here we have 15 students, that means I have 15 datas. Then how I will calculate the first quartile? So it is, if it is odd, that means it is 15 plus 1 divided by 4. Just remember, we have 4 quartiles. So if it is even, it is okay. If it is not, then you will plus 1 or any odd number to make it divisible by 4. And if it is divisible by 4 and you get the term that is known as quartile range. Just see here, it is odd, that is 15. So it is n equal to 15, 15 plus 1 by 4, it becomes 16 by 4, 4. That means it is the fourth term, 1 2 3 4. So 55 will be the first quartile deviation. Uh, First quartile, not deviation, it is the first quartile for your this set of data. So I will show you the third quartile. Third quartile is the 12th term. If the first is 4, then just calculate the 12th term, that is 5 6 7 8 9 10 11 12. That means it is 78. The 78 will be your third quartile. So like this. And what is your quartile deviation? It is the third minus first divided by 2. So third is 78, first is 55 divided by 2. So this becomes your 78 minus, quartile division is 78 minus It is wrongly written here. It is actually 55. So 78 minus 55 divided by 2. So whatever you got the answer, it will be your quartile deviation. And this is more specific than your range. Okay. So quartile ଆମେ କ'ଣ କରିବା? So if it is odd, it is n plus 1 by 4. You just get the which term is your first quartile. Just count 1 2 3 4, and the third quartile it will be your 12th term. The first is 4, second one will be 8, third one will be 12, the 12th term. So that will become 78. So 78 minus 55 divided by 2, it becomes your quartile deviation. And the third one is mean deviation. So mean deviation is 1 by n xi minus a. Just see here, these are some datas, that is 30 40 50 like so on. I just calculate the mean value by adding all these numbers divided by 10, it becomes 64. Okay. So 64 is the mean. If 64 is the mean, so the absolute deviation will be, the first data is 30, the mean is 64. What is the difference? 34. The 34 is the deviation now. 40 64 24, 50 64 14, 55 64 9, 60 64 4, 65 64 1, 70 64 6, 80 64 16, 90 64 26, and 164 it will be 36. It is not written here, it will be 36. So all these differences or deviations will be, should be in a tabulation format. Okay. And you have to add all these terms, and it should be divided by 10, and you will get the mean deviation, that is 13.4 here. 13.4 here. So like this, the mean deviation is calculated. Just find the mean value first and correlate what is the deviation from your data collected with the mean value. And always remember that your difference is a magnitude value, that it should not have any plus or minus symbol. That means if your data is having lesser number, then it is positive. If your data is having higher number, it is also positive. So it is the magnitude, it is the difference. The difference should not have any plus or minus sign. My Just remember this thing. Okay. So this is direct method. If we have a set of data with some frequency, just see here, this is a set of data with some frequency. 38 having 7 times, 43 9 times. So how to calculate the mean deviation? So to calculate this mean deviation, you should have a tabulation format, and this data is just written here: observation and frequency. The first is the multiplication of frequency with observation. 38, just see here, I just I just calculate the first calculation. Okay. The observation is 38, the frequency is 7, it becomes 266. It is correct. Okay. So like this, all these multiplications are put here, and everything is, yeah, undergo summation, and the value becomes 2634. 2634. And we have the total frequency 52. Total frequency 52. And we have the summation of all these data, a frequency into observation, 2634. So we have 2634 divided by 52 is the total frequency. It becomes 50.65384,615. So this number is here, which is our mean. If it is 50.65384,615, then we have the first observation 38. So how my first observation is deviated from the mean value? It is minus 38. It becomes minus, okay, 12.6538. Just see here, 12.6538. Then the magnitude, it is the absolute deviation. The minus symbol becomes plus, and after that we have multiplication of frequency with this absolute deviation. That is, this thing is multiplied by 7. It becomes 88.5769308. So like this, all these data are computed or calculated, and you will get your summation of data from the last column, that is fi frequency into absolute mean deviation, and all these data gets summation here. And after that, your your mean deviation will be fi into absolute mean deviation divided by number of frequency 52. Then this will be your 8.82, 8.22. So 8.22 will become your mean deviation of the set of data you have. So you have to calculate like this, and I think you are allowed to carry uh, a simple calculator for MEV-19 paper, which you are allowed to use during your examination. So like this, the data are calculated. Okay. So observation, this is the frequency. So multiplication of these two will be fi into xi. So the deviation from the mean, it is can be calculated from your mean value. So mean value from this set of data. So mean value will be fixi by n. So it will be 50.65 something. So then you have to you have to subtract your 38 minus this, 43 minus this, and so on. Then the magnitude, then multiplication of absolute mean deviation with your frequency. You will get your summation values, and you will get the mean deviation from this set of data by dividing the fi into xi minus x bar divided by 52. That is the number of frequencies we have, 8.22. So like this the calculation is made. The standard deviation, it is very popular, and it was this term was coined by Carl Pearson in 1823. This concept also, and it is the measure of the measure that prevails all the features that other measures lack. So basically, it is considered as an ideal measure of deviation, standard deviation. The square root of standard deviation is known as variance. The square root of standard deviation is known as variance, or root mean square deviation, and it is denoted by Greek letter sigma. Standard deviation value is high or low when there is more or less variation among observation respectively. So the standard variation, standard variation or deviation, standard deviation equal to the mean square we have, that is the xi minus x bar. This is the absolute mean deviation. No, this is not the absolute mean deviation. This is the mean deviation square divided by number of observation we have, n. And if our data is having some frequency data, then f is multiplied. So the square root of fi xi minus x bar square divided by n. If it is a grouped frequency data, then this will be mi minus x bar square by n, where mi is the midpoint of the ith class interval. Let's we have some um, problems. That is, these are the data we have. So the mean value is calculated at 64, This is the main value. So the square of all the observations. So the first data is 30. So 30 minus 64 square. So just see it. The minus value gets squared and it becomes plus. So your square of all the differential values will become in positive value, as positive value 4290. So like this the 10 calculations were made, and this is now divided by 10. Square root of 4290 divided by 10, it becomes 20.712, which is the standard deviation of this set of data. So for a particular set of data, first calculate the average or mean, then find out the difference square of every data you have collected, then uh, sum all these differential data, then find the standard deviation by the root square of your 4290, that is the summation value, divided by total number of data we have. That means here standard deviation is 20.712. So this is the direct method, a simple set of data. If we have a data with frequency, then in the same way the data with frequencies are written in a tabulation format. Fi xi is calculated, xi minus x bar, the same way it is calculated, and the next row is not the magnitude, it is the squaring. And if it gets squared, then what happen? We have no negative sign, only the positive signs are here. Then the last row will be frequency into summation, in multiplication by the square of the differences we have. Then we have the data like this. Then after that, all these sections gets summarized. That is frequency is 52, FI 2634, and here the last row having FI minus x bar square, it is 6511.769. Then what is standard deviation? It is the value we have collected, 6511.769.231 divided by 52. Then the standard deviation from a set of data with some frequency, with a set of data with frequency, it is give the result, that is 11.19045,716. So like this the standard deviation is calculated. Then a relative measure of dispersion, as already mentioned, your coefficient of range, it is the highest value minus lowest value divided by highest value plus lowest value. So in my previously I have mentioned wrongly, that is summation is the numerator and h minus l is the denominator. Actually the differential, that is the subtraction, is the numerator, and addition is the denominator. Okay. So where h minus l, highest value lowest value, highest value lowest value, minus and plus, just you just arrange your all the data in ascending order, and find this coefficient of range. Then similarly coefficient of quartile deviation, it is quartile deviation means it is the first quartile and third quartile. So for your uh, coefficient of quartile deviation, the calculation will be q3 minus q1 divided by q3 plus q1. So q3, it is the fourth term, sorry, q3 it is the 12th term, and q1 is the fourth term. So the first step is to arrange all these observations or data in ascending order. So this is already arranged ascending order. So the range, so how to find the range? It is the maximum value 92 and the minimum value 37. The range is 55. So coefficient of range, it is h minus l by h plus l. So h minus l is 55. So h plus l means it is 37 plus 92. It becomes 129. So your coefficient of range, it becomes 42.63%. Okay. So now compute the quartile. So quartile is same because it is 15 observations are here. So it is odd. So that means it is n plus 1 by 2. So 15 plus 1 by 2, that means yes, sorry, n plus 1 by 4, because it is quartile. So 15 plus 1 by 4, it becomes 4. So the fourth term is 1, 2, 3, 4, 55. And the 12th term is 78. So here, in the same way, your quartile deviation is calculated, that is 25 by 131. It becomes 19.08%. So like this, you have to calculate all these deviations: standard deviation, coefficient of range, coefficient of quartile deviation, coefficient of mean deviation. So mean deviation is coefficient of mean deviation. It is mean deviation, uh, that is your summation of xi minus x bar divided by central tendency measure, that is your mean, that is your average. Okay. Coefficient of standard deviation. Coefficient standard deviation is standard deviation divided by mean x bar. That is standard deviation is sigma. X bar is the mean or average value. Then your coefficient standard deviation is sigma by x bar into 100. And this measure is also known as coefficient of variance, that is CV. So coefficient of standard deviation or coefficient of variance, it is standard deviation divided by mean into 100. Okay. So then, so up to this, anyone having any question to ask or anything wish to share or anything else? କି କିଛି ଯଦି କହିବା ପାଇଁ ଚାହୁଁଛ ବା ପଚାରିବା ପାଇଁ ଚାହୁଁଛ ପଚାରି ପାରିବ।
Sir, in exam that problems will come, the
Yes,
numerical.
yes, yes, definitely. They will put a table before you in a particular question, and they are asking you find out the mean deviation, standard deviation, variance of the set of data is given above, like this. Okay. So here we have here generally we have two set of data, that is direct data, that is very clear. And if you have a frequency of data, just remember that frequency will be multiplied by the number of observations, and accordingly the mean deviation or the standard deviation is calculated. For standard deviation it gets squared, for mean deviation only the difference between the two values. Okay.
Yes, sir. So
So I,
sometimes it will ask discrete data, we have to make continuous like this.
if,
So,
if it is discrete data, then you have to make it ascending or descending order. So for any question you are facing, just make it ascending order.
no, I'm asking about grouped. Discrete
Okay,
means
okay. Discrete data, then you
mm,
have to you have to you have to take the midpoint. Let us 0 to
yes,
4.
class
It becomes
interval.
2. Interval, right?
Class interval.
Yes. So you have to multiply that interval with the data you have. Okay.
Yes.
Frequency. So I think 1 hour is covered. So let's have some 2-3 minutes break. I am thirsty now. Okay. So after a few minutes, 3 to 4 minutes, we will again continue the class. So till then, you are allowed to have some fresh. So take a fresh है जाओ पहले. Then we will continue. Okay. Am I audible, students? Okay. So let's keep this one. This is no.
Yes, sir.
Okay, okay. So mute. Please mute. So next we have then next we have, just wait, time series. So then we have a parameter sampling, non-sampling error, sampling distribution, degree of freedom, standard deviation and error, correlation regression, statistical inference, that is point and internal estimation, sample size determination, and hypothesis testing. So sampling, as we know, the sampling is an important part to carry out a particular research work, because uh, your central part of any research is to collect the correct sample from your study area, and if are collected the proper sample, then your analysis will be made accordingly, and you will have your required or required data for your expected outcome. Then in some cases, whenever we are going to collect the sample, or in our sampling process, there are some sampling errors are remain. It might be due to two reasons. uh, that is the that is sample error is one of two reasons for the difference between an estimate of a population parameter and the true but unknown value of the population parameter. The sampling error for a sample is unknown, but when the sampling is random for some estimates, for example, sample mean or sample proportion, theoretical methods may be used to measure the extent of variation caused by sampling error. So this sampling error, it is not instantly known during our sample that what type of error we are coming under, or what is the error that has been committed by the researcher or the scholar. And if you have a major sampling error, then your total project may be rejected for acceptance. Okay. And in this part we have learn about the parameters, sampling, non-sampling error, sampling distribution, what is degree of freedom, what is standard deviation, error, etc. Then parameter and sampling, as we know, sampling is some part of an aggregated or totality of the on the basis of which a judgment or inference about the agreement or totality is made. That is, it's the sample should be a representative of a whole lot of sample. For a big mass of sample, the sampling may be done in some specified region, or for a small size of sample, a only one or two times the sampling is done. Like if you are cooking rice, then then two to three times in between the cooking, we just take one or two rice piece, and just check the smoothness or softness of that rice, whether it is properly cooked or not. That means that one or two rice represent the whole rice lot in our uh, utensil or pot in which we are cooking. So like this, the sampling should be done very precisely, And targeting before targeting a particular project work, you have to design accordingly what will be the sample and how your sample should be done without any error. So most but uh, you have to take precautions to carry out your sampling. Okay, so sampling can save time and money if you have a good sampling procedure. A sample study is usually less expensive than a census study and produces a result at relatively faster speed. If you are going for this analysis of the total sample you have, then lots of time, lots of money will be used. But if I have targeted a small sample from the huge lot, then my expenses, my time will be saved. Sampling may enable more accurate measurement. For sample study is generally conducted by trained and experienced investigators. Sampling remains the only choice when a test involves the destruction of the item under study. Sampling remains the only way when population contains infinitely many members. Sampling usually enable to estimate the sampling error and thus assist in obtaining information concerning some characteristics of the population. So like this, these are the merits of sampling. Then collection of all items about which the information is desired is known as population. They are the general terms. I just skip these ones. Then sampling and non-sampling errors. Sampling surveys do imply the study of small portion of population, and as such, there would naturally be a certain amount of inaccuracy in the information collected. This inaccuracy may be termed as sampling error or error variance. In other words, sampling error are those errors which arise on account of sampling and they generally happen to be random variations. So during sampling, some unintentional errors may come, and if it is inaccurate, then we have some error which is known as sampling error or error variance. Sampling error occur randomly and are equally likely to be either direction. Just go through these things. Then we have, as opposed the sampling error, we have non-sampling error which may creep in during the process of collecting actual information, and such error occur in all surveys whether census or sample. We have no way to measure non-sampling error. Non-sampling means which samples had not been under our investigation. Then that error, we do not have any process or any way to measure that sampling error, non-sampling error. Sampling distribution, the distribution of statistics may not be same as the distribution of population, because population involve the total lot, but the sampling or the distribution of statistics involve the sampling we have made. So we are often concerned with sampling distribution in sampling analysis. If we take certain number of sample and for each sample compute various statistical measure such as mean and standard deviation, then we can find that each sample may give its own value for the statistics under consideration. All such values of a particular, nah, we can have sample distribution of mean or the sample distribution of standard deviation or the sample distribution of any other statistical measures. Sampling distribution of mean. So for sample distribution of mean, just see here. So this is the mu for a normal population. Mu is the mean and sigma is the standard deviation. Then the normal with mean mu into x equal to mu, and standard deviation it is sigma into root over of n. So then our normal variate it is another parameter, it is denoted as z, and it is equal to x minus mu by sigma root over of n. That is, x is the observation, mu is the mean, sigma is the standard deviation, and n is the total number of observation we have. So this is our normal variate z. Is then sampling distribution of proportion. So sampling distribution of proportion, it is proportion means it is measure of the attributes. Let us we have the population is divided into two: mutuality exclusive and collecting exhaustive classes. uh, so we have two classes, that is, one is smoker and one is a non-smoker. So let us, n is the total population size, x is the number of people out of n possessing a particular attribute. That means x may be number of smoker or non-smoker. Then pi is x by n, that is number of people having some particular attribute divided by total population size. Then for sample distribution proportion, it is equal to z, which is equal to, it is capital Z, it is equal to x minus n, that is population size, into pi, that is x by n, divided by root over of number of observations small n into pi into 1 by n. So this is the formula we have. This is sample distribution of proportion, and accordingly you have to calculate whether your, for a particular attribute, what is the sampling distribution of proportion for your smoker as well as a non-smoker by using this formula, that is z equal to x minus n pi divided by root over of n pi 1 minus n. Then we have the t test, that is known as the t variable or t distribution, which is related to our x bar minus mu divided by s1 by root over of n. So this is for a particular population where our standard deviation it is written as s, and your x bar it is the mean, it is the mean, and it is the mean. Okay, so that is a square, it becomes your variance. So variance will be 1 by n minus 1 root over of, sorry, summation of xi minus x bar square, that is your simple variance. So sample variance it is your square of standard deviation. So students t distribution, so this is the formula. Then we have the chi-square test. So this is the, this test is carried out when we deal with collection of values that involve adding of squares. Because it is chi-square, that means it is adding of squares. Variance of sample, that is your s square, requires to add a collection of squared quantities, and thus have distribution that is related to chi-square distribution. So suppose we have the datas, that is x1, x2, x3 up to xn, and n is the population size. Then we have the distribution of statistics, that is xi minus x divided by standard deviation square. Each chi-square distribution with degree of n is the degree of freedom here. Alternatively, we can retain the equation as summation of xi minus x by sigma square, which is also equal to n minus 1 s square divided by sigma square. So n minus 1 is termed as degree of freedom. So degree of freedom is nothing but your total number of observation minus 1. Why it is minus 1? Because the observation which is under calculation is excluded from the total number of data, so total number of observation we have. If we have a total number of observation n, and I am just calculating the distribution for a particular observation, then that observation is gets subtracted from the total observation I have, then it becomes n minus 1. So n minus 1 is known as degree of freedom. That that means for a set of data, the degree of freedom is always n minus 1. And why it is minus 1? Because the data which is under investigation is subtracted, because that data have no freedom, so that is known as degree of freedom. Okay, so that data is under investigation, so that is having no um, flexibility or freedom. So that's why this is known as degree of freedom. It is n minus 1. So if I change this equation, I have n minus 1 a square by sigma square, which is the chi-square equation for your set of data. Then I have f test, that is Snedeker's f distribution. If x and y be the two independent sample, such that x has chi-square distribution with d1 degree of freedom, and y has chi-square distribution with d2 degree of freedom, then distribution of statistics will be or f test will be f equal to capital X by d1 by y by d2 is Snedeker's f distribution. Alternatively, suppose we have some independent samples of size n1 n2 respectively for normal population having same variance, then your equation can be written like this, that is summation of xi minus x square divided by n1 minus 1. So this is one set of data, and another set of data is y, so that's why it is yi minus y square by n2 minus 1 square 1. So it can be written as sx square by sy square. So as already highlighted, n1 by n1 minus 1 will be the degree of freedom for first set of data, and n2 minus 1 will be the degree of freedom for your second set of data, and s square becomes your variance. So this equation, it is nothing but your variance, s square. So sx square by sy square. So in this way you have to calculate the f distribution. Then degree of freedom, I just read out the lines. The number of independent observation which makes up a statistics is known as the degree of freedom, may be written as small d or small f associated with that statistics. Number of independent observation, that means whenever we are calculating a descriptive statistics or a measurable quantity for a particular observation, that observation becomes dependent and the rest of the observations become independent. So the number of independent observations are known as degree of freedom for a particular set of data. So degree of freedom is the number of values in the final calculation of a statistic that are free to vary. It is written as that are free to vary. That means these are having freedom. In general, degree of freedom of a statistics, it is the number of independent observation minus number of parameters under estimation or it is estimated, that is n minus 1. Standard deviation, sorry, standard error. We have seen that different sample of the same size from the population will yield different values of statistics under consideration. Say sample, a measure of the variability in different values of a sample mean is given by standard error of the sample mean. Standard error of a statistic is the standard deviation of its sampling distribution. Standard error play an important role in statistical hypothesis testing and interval estimation. Standard error give an idea about the reliability. It gives the reliability of it gives the reliability and precision of the estimate. Also, standard error decreases when sample size increases. Standard error of some important statistics are given below. If sample mean it is the average, then standard error will be standard deviation divided by root over of n. If your question in a question you have some sequence of datas in and and they're asking that find out the mean and standard error, then you have to calculate the things according to the equation given above. For a sample mean, it is a sample error sigma by root over of n. If it is sample variance, then your sample standard error becomes different, that is sigma square by root over of 2 by n, and this is the sample variance. If it is the sample variance of a population, it is sample variance of a sample. If it is for a population, then it is your sigma square divided by 2 by n becomes n minus 1. So this becomes your degree of freedom. Sample proportion p equal to x by n, and where your standard error becomes p 1 minus p divided by n. So it is the sample proportion. So in this way, the standard error is calculated and the standard error formula is different for different statistics. For mean, it is sigma by root over of n. For sample variance, it is sigma square multiplied by root over of 2 by n. If it is sample variance for a population, large population, it becomes n minus 1, and if it is proportion, then it becomes p1 minus p by n. Correlation and regression. So Charles Spearman's coefficient of correlation is the technique of determining the degree of correlation between two variables in case of ordinal data where ranks are given to the different values of the variable. The main objective of this is to determine the extent to which the two set of ranking are similar or dissimilar. So this is just a similarity index type. So the similarity in the sense we are just comparing both the datas and find out the correlation between them. So the Spearman coefficient correlation R, it is symbolized as R, which is equal to 1 minus 6 summation of di square divided by n square minus 1, where di is the difference between the ith pair of the two variable. Ith means it is the, if it is first variable, so first variable of the two sets. If it is 10th variable, then 10th variable of the two sets. Oh, sorry, 10th pair of the two variables. And n is the number of observation. The coefficient measure assumes that there is a linear relationship between two variables. Two variables are causally related to means that one of the variable is independent and the other one is dependent. A large number of independent causes are operating in both variables so as to produce a normal distribution. So read out these things. Then we have the Carl Pearson formula. Lots of formulas are here. Then Carl Pearson formula, it is now reduced to this formula. This is Spearman's formula. Sorry, the There is another formula, that is Carl Pearson formula. This is your summation of first set of data difference into second set of data by number of observation minus individual summation divided by n, divided by the same way the first set of data summation square divided by n minus first set of sum. This is the squaring summation, and this is the individual summation square, and the same way the second set of data are here. So this is another method of uh, to find out the deviation. Lots of things are here. Simple regression analysis. This is another regression. It is the determination of statistical relation between two or more variables. In simple regression, we have only two variables. One variable is independent and other is dependent. Regression can only interpret what exists physically. There must be a physical way in which independent variable x can affect dependent variable y. This is a physical way in which independent variable, let it be x, which is affect the dependent variable y, where symbol y denotes the estimate value of y for a given value of x. Let's have some equations. This is a least square method. This is least square method, and the equations are like this. Just go through these equations, and just remember the x and y are the two sets of data, like this. Then you have the multiple correlation and regression, where there are two or more than two independent variables. The analysis concerning relationship is known as multi-correlations, and the equation describing such relationship as the multiple regression equation. We here explain multiple correlation regression taking only two independent variables and one dependent variable. So multiple regression equation, y equal to a plus b1 x1 plus b2 x2. I think these things are not in your syllabus. These are very complicated equations. So let's keep this one. Partial correlation we have. I will share this PDF. Just go through this, and this is very simplified version. And your IGNO, that one, IGNO material. It is a very complicated equations are here. Just see here, mode L plus F1 minus F0 by 2 F1 F0 F2. These are very complicated. So just to make your understanding clear, I have just downloaded this PDF from the University of Uttarakhand site. Now, this is also Open University, Uttarakhand Open University, and its materials are very good. These are some post estimation equations are here. Everything is related to standard deviation, variance, mean, median, mode. We have some test, chi-square test, t-test. All these things are here. Let's have this problem. Okay, so let us on the following population of size 4, that is 18, 20, 22, and 24. The population mean is summation of all this divided by 4 becomes 21. The population variance, it is the square of the summation divided by total population. So all these are get squared. This is minus actually. Okay, so all these are get squared divided by 4, it becomes 5. So now we collect all possible sample of size 2 from this population and calculated sample mean. The formula is this one: sample variance, that is a square, and modified sample variance, that is S1 square for first set of data. Then we have the sample, the two set of data. This is the first one, this is the second one. Just see here, 1818, the mean is 18, 2018, 19, 2218, 20, 2418, 21. These are the mean. Then we have a square. This is the standard deviation square, or we can say this is the variance, and calculated by using this formula. And similarly, the S1 square, this formula, it is also calculated, and the figures are given here. So from that, the average is calculated like this. So in this way, you will face some problems in this part. Then consistency, it is related to your accuracy. If you have more close to the true value of the absolute value, then your consistency or accuracy will be there. And it is not always certain that your data are precise, so accurate. This is not the way you should think. It always related to how closeness, or how your estimate value or your observation is close to the true value or absolute value. Sufficiency: an estimator should use an as much as possible the information available from the sample. This property is known as the sufficiency. Then efficiency: an estimator should have a relatively small variance. This means that the most efficiency estimator among a group of unbiased estimator is one which has the smallest variance. This property is technically described as the property of efficiency. Keeping in view of the above property, the researcher must select appropriate estimator for his study. Then we have interval estimation, and then all these things are there. Then under testing of hypothesis, already we have covered this part in our first or second class. Then what is hypothesis, characteristics of hypothesis, what is null hypothesis, and alternative hypothesis. All these things are already covered up. So I just keep this part, and just the last one, that is ANOVA test, which is very one of the important part that should be covered. Yes, this is it. In your syllabus only ANOVA test is there. So in this part, unit 11, we have chi-square test, T test, F test, J test, Q test, and ANOVA test. I just rapidly go to the mathematical formulas. The chi-square formula is chi-square equal to summation of, this is observed value minus expected value square divided by the expected value. So this is your chi-square formula, and it is a statistical measure of difference between the observed and unexpected frequencies of the result of a set of event or variables. Chi-square is useful for analyzing such differences in categorical variables, especially those nominals in nature. Chi-square depends on the basis of size of the difference between actual and outcome result, the degree of freedom, and sample size. Chi-square can be used to test whether two variables are related or independent from each other. It can also be used to test the goodness of fit between an observed distribution and a theoretical distribution of frequencies. So this is the formula you will use. So in your exam, a set of data will be there where observed values and expected values are given. So just put this formula and get your answer. Then t-test. a, a t-test is a type of inferential statistics, that it is not absolute, inferential, to find out if there is a significant difference between the two means of two groups, the means of two groups. There are two set of data having two means. So this test is applicable where we have means of two groups. It is mostly used when the data set, like the data set recorded as the result from flipping a coin 100 times, would follow a normal distribution and may have unknown variances. So it is used as a hypothesis testing tool, looks at the t statistics, t distribution and degree of freedom to find out statistical significances. So we have the t test, ambiguous t result will be there. Where is the formula? Yes, this is the calculating how the t test is calculated. Calculating a t test requires three key data values. It includes mean value from each set of data and standard deviation of each group and the number of data values of each group. The outcome of the t-test produce a t-value. The calculated t-value is then compared against the value obtained from a critical value table called the t-distribution table. This comparison helps determine the impact of chance alone on the difference and whether the difference is outside that chance range. The t-test questions whether the difference between the groups represent a true difference in the study or if it is possibly a meaningless random differences. So we have the t-test equation here. The t equal to x1 minus x2, that is the mean of first test minus the mean of second test, the second set, divided by s square. This is the variance. Square root of s square 1 by n1 plus 1 by n2. So n1 and n2 are the mean 1 and mean 2 is the average value of the set of data. N is the sample size, that is for first set and second set, and n minus 1, as we know, this is the degree of freedom. So this is the formula for your t test, that is x1 bar minus x2 bar divided by square root of s square 1 by n1 plus 1 by n2. So for t test, we'll require the mean and the standard deviation with number of observation we have made. Then we have equal variance or pooled t-test. This is another category, and this is used when the number of sample in each group is same. Very good. This is another important part. When the number of sample in the group is same, that is n1 and n2 both are same, then instead of writing n1 minus 1 and n2 minus 1, the degree of freedom is written as n1 plus n2 minus 2. So in this way, the t value is calculated. That is a square n1 minus 1 s1 square plus n2 minus 1 s2 square. Then unequal, if it is unequal, then this is the equation, and this test is also known as Wells t test, where the two sets of data are unequal. This one x1 bar minus s2 bar divided by s1 square by n1 plus s2 square by n2. The t value is calculated. Then F test, F letter is come from the uh, scientist or mathematician Fisher. F test is used to the two independent estimation of population variance. Two sample have same variance S1 S2, then F will be larger estimate of population variance divided by smaller estimate of population variance. So we have to calculate the standard deviation, make it square and become variance. So S1 square by S2 square. So degree of freedom for large population variance is V1 and small is V2. The null hypothesis of two population varies is equal that the null variation is equal to S1 equal to S2 square. S1 square equal to S2 square. Then we have the Z test. It is a statistical test used to determine whether two populations means are different when the variance are known and the sample size is large. Variance is known and the sample size is large. So in this condition, the two populations are under Z test. So formula of Z test, Zr minus Zp by Sez. So Z test is used to determine whether two population means are different and population variance is known. This is also called large sample test. This is also conducting many type of tests. One sample, two sample, location test, pair difference test, etc. So a Z test is a statistical test to determine whether two population means are different when the variances are known or sample size is large. It is a hypothesis test tool in which Z statistics follows a normal distribution. So just go through these things. I just cover the uh, ANOVA test, which is important. Well, this is the Q test. Formula is QS equal to YA by Y minus YB by AC. AC is the standard error. YB is the smaller of the two means being compared, and Y is the larger of the two means being compared. Now, this is different from the normal calculation. Honesty significant difference, HST. Just go through this, okay? Then we have the very famous ANOVA test, which is known as the analysis of variance. And this addresses precisely the problem just described. It accounts for the rapidly expanding degree of freedom in a sample as variables are added. If variables are added, it is generous that degree of freedom is automatically increases. For example, looking at hours versus score is one pairing and sleep versus score is another pairing. Grade versus score, it is the third. And meanwhile, all those independent variables interact with one another. So we have three set of data, that is hour versus score, sleep versus score, and we have grade versus score. Okay. So these tests, the variables of interest after calculation have been run in F test, which is the found variation of the average of all the pairs. Okay. The higher this number, the stronger is the relationship and significance is usually set as 0.9 pickup. So if your ANOVA test is more towards higher number, then it is good because your relationship between two groups are become very stronger. So reporting ANOVA results usually require the use of built-in calculators such as the those found in Microsoft Excel, as well as dedicated statistical programs such as SPSS. So all these are advanced tools which are there in Microsoft Excel as well as SPSS. These tests does is compare the difference between means of values rather than comparing pair of values. So this is not head to head comparison. This is the comparison between the means of the two values or two pairs. The values of the Turkey test, that is Q, is given by taking the absolute value of the difference between pair of mean and dividing it by the standard error, which is already given in that equation, that is QS, and it is determined by a one-way ANOVA test. So ANOVA test is of various types. ANOVA test one way, ANOVA test two way, and ANOVA test, I think it is multiple way. So standard error is in turn the square root of variance. An example. So analysis of variance is an analysis tool used in statistics that split an observation aggregate variability found inside a data set into two parts, that is systematic factor and random factor. The systematic factor have a statistical influence on the given set of data, while the random doesn't. Another test is to determine the influence that independent variable have on the dependent variable in a regression study. So analysis of variance is a statistical method that separate observed variance data into different components used for additional test. A one-way ANOVA is used for three or more group of data to gain information about the relation between independent and dependent variable. So one way रे ଆମର କେତେଟା ରହିବ minimum 3 or more group of data ରହିବା ଦରକାର. I mean to have the idea about the relationship between dependent and independent variable. If no true variance exists between group, ANOVA F ratio should be equal or close to MST by MSC, where MST is summation of ti square ni minus g square n g to the power 2n divided by k minus 1, where MST is known as the mean sum of square due to treatment and mean sum of square due to error. So this is your F ratio in ANOVA test, that is mean of square during observation or treatment and mean of square due to error. So it is the first step in analyzing factors that affect a given set of data. Once the test is finished, an analyst perform additional test on the methodical factor that measurably contribute to the data set inconsistency. In the analysis, the analyst utilizes the ANOVA test result in an F test to generate additional data that align with the proposed regression method. Let's go for an example. A researcher might, for example, test students from multiple colleges to see if students from one of the college consistently outperform students from the other college. In a business application, R&D researcher might test two different processes of creating a product to see if one process is better than the other in terms of cost efficiency. So we have two colleges having business application or R&D by the research and development activity, and here we are comparing which process is better with respect to the economic point of view. The type of ANOVA test used depends on a number of factors, that it needs experimental. ANOVA is employed if there is no access to statistical software, resulting in computing ANOVA by hand. It is simple to use and best suited for small samples. With many experimental design, the sample size have to be same for the various factor label combinations. ANOVA is helpful for testing three or more variables already stated. It is similar to two samples, multiple two sample t-test. It results in fewer type 1 error and appropriate for a range of issues. ANOVA groups difference by comparing the means of each group, and it includes spreading out the variance into diverse sources. It employs subject test group between groups within groups. One way and two way. There are two main type of ANOVA, one way and two way. There are variation of ANOVA. For example, multivariant ANOVA, M ANOVA differ from ANOVA as the former test of for multiple dependent variables simultaneously, while the latter accesses only one dependent variable at a time. Two-way having the two-way having the multiple type, where one way is the one-way type. So a one-way ANOVA evaluates the impact of sole factor on a sole responsible variable. It determines whether all the samples are the same. One-way ANOVA is used to determine whether there are any statistically significant differences between the mean of three or more independent groups. The two-way ANOVA is an extension of the one-way ANOVA. With one way, you have one independent variable affecting a dependent, while in two way, there are two independent affecting the dependent. For example, if two-way ANOVA allows a company to compare worker productivity based on two independent variables such as salary and skill, it utilizes the observation, the interaction between the two factors, and tests the effect of the two factor at the same time. So in two-way ANOVA, we have two variables, two independent variables that are affecting the dependent variable. For example, this one for a particular company, if the productivity, that is independent variable, it may be dependent on salary and skill, then test may be considered as the two-way variable, that is two-way ANOVA. So in this way, the ANOVA test is carried out. So this test is related to your variance, the analysis of variance. You just calculate the square of the standard deviation, and if it is one way ANOVA, so this is one independent affecting the dependent variable. If it is a two-way ANOVA, this is the two independent affecting the dependent variable. So in this way, the things are going on. So there are a lot of descriptions, equations are here. Just right, just you should note down all the mathematical equations of each descriptive statistics, starting from mean, median, mode to ANOVA test. We have discussed various central figures, followed by your standard deviation, variance, standard error. We have range, coefficient of range, quartile, coefficient of quartile. Then we have different tests: chi-square test, F test, T test, Q test, ANOVA test. So how a sample error, non-sampling error, how hypothesis testing is done, how what is null hypothesis. So all these are covered up. Just go through the things very um, concentrately, and you will get the things very clear. Okay. and I will share this PDF with you. So in this PDF, the equations are very clearly written, as well as the language is very simple to understand. And just try to remember the formulas and apply these formulas to the problems you have faced in your examination. So this part, that is block 3 of MEV-19, is very vast, very large. It is not um, possible to cover all within 2 hours. So as far as possible, I have described, I have demonstrated, I have highlighted the important things that are generally used for a project work during data analysis or data interpretation. So now the platform is open. So now the mic is with you to ask some questions, and I will try to answer it. So on you, students. ହେଇଗଲା time. Hello. Anyone having any question, or else anything related to your program or related to today's class or any other paper related to examination, you may ask. We have we have 5 minutes for discussion, or else we will wind up the class.
Sir, from this block unit 3, that one problem will come, and others
Not
are,
one problem. Just see, you will face 10 questions from
yes,
four
sir.
blocks.
Yeah,
10 questions from four blocks.
problems.
Actually, you will get I think 14 questions from four blocks,
Four blocks.
and out of 14 you have to answer 10 questions.
Yes, sir.
So if statistically we calculate, so on an average 3 questions from each block, 3 to 4 questions.
Yes, sir.
So you expect a minimum 3 questions from block 3 MEV-19.
That the theory question, suppose one question I saw that the difference between correlation and regression, draw a regression line, like these questions are given.
Yes. These type of questions is will ask, and also question related to your mathematical calculations will be there.
Acha. Okay. No, actually, central tendency, mean median, mode, standard deviation, variance, it's okay. But chi-test, F-test, Z-test, so difficult to understand.
So all these tests are carried out to compare different set of groups, and to made a conclusion that which set of group is acceptable over another.
Acha. Yes.
So that's why these tests are done in different field. Okay.
Actually,
Yes. So Josnalani, thus you are advised to add my number in your WhatsApp group,
yes, sir.
and my number is just I am giving my name, just
Huh.
putting my name in your chat box. So this
Yes,
is my
sir.
number. This is my number.
Smriti Rekha madam is the admin. Smriti Rekha madam, just take its son number.
Yes, ma'am. Yes, ma'am. Today I will add.
Okay, so just add my number. I will share the PDFs I have. Okay, so
Yes, ma'am.
go through that PDFs, and also the PowerPoint presentation, if that is there for your MEV-19 course.
Sir, previous PDF also will send it.
Okay. I will share. I will share. No problem.
Okay, thank you, sir.
So
Okay, sir.
may I close the session now?
Yes, sir. Thank you, sir.
Okay, so thank you to all. So tomorrow is the last class, and that class will be related to the project writing, the scientific report.
Yes.
So that will be interesting one. And after covering that block, we will discuss all the four units, all the four blocks, one, two, three, four. Then anyone having any queries related to anything related to MEV-19, you may ask tomorrow, and this will be our last class for today for this session. Okay.
Okay,
And
sir.
another thing, um, I may be I may be take another paper, that is the electric paper, which is assigned to me. The figure is not yet with me, one electric paper, and this is during the third or fourth week of April. So if you anybody we anybody have the same elective, then we will meet again in that class again. Okay. So till then, thank you to all.
Thank you.
Thank you, thank you, thank
Thank
you.
you, sir.
Thanks.